Black gold, the fluid that keeps us moving, unleashing the energy trapped within the earth. One of the most utilized natural resources, crude oil taken from the earth has tremendous chemical potential energy. It also has tremendous potential for disaster. But how does it go from a liquid taken from beneath the earth to a fuel that makes your car run or allow planes to fly? Crude oil is a naturally occurring mixture of hydrocarbons, compounds made of hydrogen and carbon atoms. Found deep underground, crude oil is the raw material that fuels modern life. But on its own, it's not very useful. That's where refining comes in. Crude oil is like a puzzle. Inside it are valuable pieces like gasoline, diesel, jet fuel, and even chemicals for making plastics. Refining is the process of separating and transforming these components. In addition to the different valuable hydrocarbons, raw crude oil also contains contaminants like sulphur, nitrogen, oxygen, and various types of salt. The salts contained within the crude oil produce hydrogen chloride when going through the oil refining process, which creates an extremely corrosive acid that causes damage to the equipment. A desalter unit is used in a refinery to remove these harmful salt impurities. The desalting process involves heating the crude and mixing it with fresh water. The salts dissolve in the injected fresh water, and the oil and water mixture are separated inside a vessel. A high voltage introduced into the water and oil mixture causes the small drops of water to combine and sink to the bottom of the tank, where it is then taken to a water treatment area. The crude oil is then heated to about 350 degrees Celsius inside of a furnace, turning it into a vapor. The vapor is sent into a tall tower called a fractional distillation column. Inside the column, the temperature of the vapor decreases as it rises. This causes different components of the crude oil to condense at various levels based on their boiling points. Heavier products like asphalt settle at the bottom, while the lighter ones like gasoline rise to the top. Distillation gives us basic fractions, but distillation isn't enough. The heavy oil fractions that are collected at the bottom of the distillation tower aren't in high demand. So, refineries use a process called cracking to break large hydrocarbon molecules into smaller, more useful ones, like turning heavy oils into gasoline or jet fuel. This process allows oil refining companies to get the most out of each barrel of crude oil. The process begins when heavier oil from the distillation process is heated to a high temperature and mixed with a hot, powdered catalyst from the regenerator. The heated feedstock and catalyst are fed into the reactor, where the cracking reaction occurs. The high temperature and catalyst break down the long-chain hydrocarbon molecules into shorter ones. During the cracking process, carbon deposits form on the catalyst, reducing its effectiveness. The spent catalyst is sent to a regenerator, where the coke is burned off with heated air, restoring the catalyst. The regenerated catalyst is then recycled back to the reactor. The cracked hydrocarbons are separated from the catalyst and sent to a fractionator, where they are separated into the different products based on their boiling points. The impurities in the crude oil, like sulphur and nitrogen, must also be removed. When these elements are contained within a fuel that is burned, they create pollutants that contribute to air and water pollution. This pollution is harmful to the environment. The harmful elements are removed from fuels with a process called hydrotreating, where hydrogen and a catalyst is used to remove the impurities from the products. The sulfur in the fuel stream is converted to hydrogen sulfide gas, or H2S, and after further treatment, to elemental sulfur and sulfuric acid. The nitrogen gets converted into ammonia. Once the refining process is complete, the fractions are further processed into end products. Gasoline is blended with additives for cars. Kerosene becomes jet fuel. Even the waxes and chemicals are used in cosmetics and plastics. It's amazing how a single 42-gallon barrel of crude oil can produce so many different products we use daily. Refining oil definitely has environmental impacts, like CO2 emissions and water usage. But modern refineries are working to reduce their footprint with cleaner technologies and efficiency improvements. As we transition to renewable energy sources, oil refining continues to adapt. ensuring we meet today's needs while protecting the planet. So the next time you fill up your car or pick up a plastic product, remember the incredible journey of the oil refining that made it possible. If you found this video informative, don't forget to like, subscribe, and hit the bell for more fascinating insights into the world of science and technology. Thank you for watching.